So, yeah, hello, welcome everybody. My name is Eric Linsos from Robert Bosch. It's really a pleasure to introduce you to our new emission model from Bosch, which we connected with PTV Vissim in the last months, and bring it also to US American emission factors. Maybe some words about our company. We are a global company with about 400,000 employees. So we are a leading software and technology companies with about 40,000 developers. We are based in Stuttgart, Germany. We are one of the biggest automotive suppliers worldwide, and we are investing more than 6 to 7 billion euro every year in research and development. And in 2019, we had several projects in different parts of our company regarding air quality. So we have our own exhaust system development. We have our own sensor development, and also air and atmospheric specialists are part of our central research. And there were different products based on air quality, and we put all these projects together in beginning of 2019 and founding in so-called internal startup called Air Quality Solutions. Within this air quality solution, we have three different products where we try to show in regards of air quality a holistic approach. So what you see here on the slide is on the left side, we have built up an emission model, what is really coming out of the exhaust pipe of every vehicle, which is now integrated in a first step in PTV Vissim. But there is also an air quality box, which is a hardware, a sensor device where we can measure all harmful pollutants like particular, like CO, like NO2, and so on in a very accurate way. And then in between there is the dispersion. So what is influencing the emissions or describing the way from, let me say, from the exhaust pipe to the measurement on the sidewalk. There is a dispersion calculation, which we call EcoLoop, where we calculating and modeling all influences from wind, weather, and air chemical, so that we have a holistic picture coming from the sender, the emissions, up to the point where we measuring air quality on the sidewalk. Today, I will concentrate on the emission part, which is now part of PTV Vissim, and I want to show you the benefits of these product. So the first slide shows maybe the main difference between our emission model and standard emission inventories, which you maybe know, like in the US, it's moves from the EPA. In Europe, we have other emission inventories like COPERT, or in Germany, especially the Handbook for Emission Factors. And what this we call a macroscopic modeling. So when here you see an example, this is a borough of London called Brixton, where we modeled with such a macroscopic emission inventory the emission on road segment, and you see it's quite an average value on longer distances. And the reason for that is because these macroscopic emission models are built to evaluate wider areas and bigger areas regarding emissions from road traffic, or even not just road traffic, also industry, etc. But today I concentrate on the road emissions. And today, but sometimes it's used to zoom into a single crossing, to a single corridor. But for these are emission inventories are not really done. So then we went into a development where we said, okay, like you have the difference between Vissim a macroscopic simulation, in Vissim a microscopic simulation. You can also do the same on the emission side, and we developed this microscopic emission model, which is based on second by second driving behavior and on single vehicle levels. So we're calculating for every vehicle coming out of Vissim, for every single trajectory, we're calculating the needed power for the next second, which this vehicle needs to drive. And based on these needed power, we go into emission map and taking out the right emission factor which is needed for the next second for this vehicle. And this we're doing for every single vehicle coming out of the emission of the traffic simulation of Vissim. And this makes it, what you see also in the picture, what makes it in a very more accurate in the way of 20-meter segments, which you can evaluate your emissions. One of the main factor or main difference why these pictures are looking so different is how traffic emission results. One of the main factors is, in this case, is dynamic acceleration of vehicles. On the top you see on the left side traffic volume. The influence factor is just one. When you have the half of your cars on the street, you will have the half of the emissions when it's an average what you're dividing. And also the traffic situation is also influences is just one, because when you're driving the half of the speed, it's 2 times longer in this area, so it will emit 2 times more emission than when it's drive faster, to be honest, more or less. But from the driving dynamic side, you have the factor 4 to 10. So driving dynamics is very higher influences on emission than, for example, traffic volume or traffic situation. And the reason for that is that exhaust systems are very good when you have a constant driving, but when you go into a transient vehicle behavior, in this case acceleration, you have more exhaust, and your catalyst had from 1 second to the other second much more to do because of the higher exhaust flow. And this leads normally, especially at older cars, this leads to much higher emissions than when you're driving in a constant speed. There was a study, it's done in Germany, but to be honest, it's worldwide the same for all vehicle types. When you have a constant driving, in this case here on the left side, which we put to 100%, it's a driving between 20 and 40 kilometers per hour. And then when you have a constant driving, which is even faster, 40 to 140 kilometers, you go even down with your emission. The reason for that is to convert your emissions in the catalyst, you need heat, and driving faster leads to more heat, and that leads to better conversion rates and reduced emissions. Just driving faster than this 140 kilometers per hour, which is not really relevant in normal driving conditions, but leads to much more emissions, because then your exhaust flow is always high because of the high power you need it by your engine, and that leads again to higher emissions. But when it comes to acceleration, the next one, you have 5 times more emission from the same vehicle. And when you see how it's split it, the next one is an acceleration between 0 and 20 kilometers, a typical acceleration after stopping on a traffic light or something like that inside a city. You have more than 6.5 times more emissions than the same car would have when it's constant driving. And this leads to the different pictures before. In an inventory, an emission inventory, you use average values like average speeds, average in this area, and this leads to this more not macroscopic picture. And when you taking single by single vehicle and taking into account all the dynamic of your traffic, then it leads to this more microscopic picture. We did a lot of development work to get a maximum accurate result out of our emission model. What you see here is in blue a measured emission, which is measured by so-called PEM system. They are on the back of the car, where the exhaust system goes directly in this analytics tool. PEM stands for Portable Emission Measurement System. And there's the analytics inside, what is really coming out at this second now out of your exhaust pipe. And in red, you see the modeling based on for example, a second-by-second trajectory out of Vissim, which have the same driving behavior like the car with the PEM system. And what you see here, it's time over NOx gram per hour, but you can also take particular in this case. We're finding every single hotspot acceleration phase, or where the vehicle is emitting more emission. And sometimes we overestimate this because the red peak is higher than the blue one, and sometimes we underestimate it because the blue peak is higher. But at the end, we're finding every single hotspot on the street with our model. So this is real driving validated emission model by such PEM systems, and our overall accuracy per vehicle drive cycle is over 85%, and the hotspot detection is over 95%. So planning with PTV microscopic simulation tool your traffic, and then modeling also with a microscopic tooling your emissions with the emission model from Bosch. We did several proof of concept and different projects together already. One of our earliest project we did in Stuttgart, which is our hometown from Bosch, and there we got an improvement of NOx, so NO2, nitrogen dioxide, of about 20%, just changing the driving behavior of the people. I want to tell you now a little bit more about this proof of concept in Stuttgart. There we took real driving cycles, so what we got in directly the data, vehicle to X, vehicle to infrastructure, the data out of the vehicle. And what you see here on the top is every line you see is speed over distance, and every line which you see is one vehicle driving in Stuttgart at a special crossing, where we have also in red at 250 meters, we have an air quality measurement device there, and you see it's directly in the acceleration zone of the vehicles, and there's a reason why it's there, because it's the worst place to position it, and this is European law that you should position your measurements at the worst hotspot places in your city, and that is exactly what you see here. There is an official measurement station in this after this acceleration phase of the vehicles, and I show you earlier that especially acceleration is the weaknesses of exhaust systems when you're accelerating. So people are accelerating at this traffic light from 0 up to 60 kilometers per hour, and then at the end of the horizon you see on the middle picture there's an S-curve where people has to reduce the speed by 10 kilometers, because this curve you can just drive about 40 to 50 kilometers per hour. With these data, we went into our emission modeling. And what you see is on the top again is the street. It's one of the main commuter streets. It's called B14. There are 6 lines, 3 in each direction, and about 100 vehicles per day going through this street. We are analyzing the direction inside the city, coming from outer Stuttgart, going into the city center from right to left. And then you see on the right side the air quality monitoring station, and then this S-curve where people has to pray. And what we see here in blue is the German emission inventory, which is used also by the city of Stuttgart there. And you see no difference in the whole area. The reason for that I mentioned before is because it's this macroscopic approach, and the city wants additional measures to reduce emission in this area, and so we developed this microscopic approach together with the city of Stuttgart to show really the difference vehicle by vehicle in this area. And you see there are 2 speed cameras before the crossing is coming, and even there we see people are afraid of these speed cameras. They're braking a little bit and accelerating, which leads to the first 2 peaks. And then you have the major crossing where 40% of the people has to stop, and this leads to this major peak because 40% of this vehicle has also to accelerate afterwards. And then people has to brake, which leads to the lowest values at 400 meter. And then there are 2 small peaks, which are also 2 crossings where just 5 to 10% of the vehicle has to stop because of a green wave. The traffic lights are coordinated quite good, but even there's possible of improvement, which I show you later. But these are the last 2 peaks. We discuss now measures with the city of Stuttgart, and the first idea was to reduce speed from 50 to 40 kilometers, which is quite easy, and in our opinion would lead to a driving behavior of the people like the green line. So they will not accelerate as hard as before. They just accelerate until 40 kilometers instead of 60 kilometers per hour. And after the S curve, which they just can drive with 40 kilometers, then they are allowed to drive faster. So we did that. We tested this measure about 2 months, and then we go again in the emission calculation. And what you see, again coming from the right side, you see the 2 peaks for the speed cameras, and they are as high as before because there the measure does not work in this area. The measure starts at the main crossing. So we see, even if we measure there again the emission 2 months or 3 months later, it's the same driving behavior, it's the same emission which we calculating out of our model. Then we were wondering at 700 meter, there was an additional, I would not say peak, but an higher emissions. And at the same time where we did our trial there, they implemented a new bus line. And this bus line the bus has to go into the normal traffic at this position every 5 minutes. So they have an additional traffic light there, which just switched to red just every 5 minutes. And this leads to, again, 5% people has to stop there. And this leads to 5% acceleration, which leads to this higher emission. Even such microscopic changes in the traffic we can investigate here. And then again, the peak, but the peak drops much earlier. And when we had a look at the driving behavior, we see people are unfortunately accelerate as fast as before, but they stop earlier at 40 kilometers per hour. So that's the reason why this peak is the same gradient, but drops much earlier because they stop accelerating earlier. And so we have here a high benefit, especially where the worst place where the measurement station is. Unfortunately, people are accelerating again a little bit between the curves. So that means here we have a negative emission, but the people comes about 5 seconds later to the next traffic light, which leads to that not that much people has to stop any longer at this traffic light. So we reduced it from 5 to 10 to 2 to 5% stops of people, which reduced also in this area the emission by about 20%. So the overall emission reduction, but just by this small measure, was about 20% emission reduction in this area of interest, and especially on the worst place, we have a reduction of about 50% of the emissions. Yeah, so what I want to show you with my slides is that when you using a microscopic modeling on the traffic side, you should also use a microscopic modeling on the emission side, because this leads to much better understanding on the emission, and afterwards on the air quality side, using this microscopic tool chain which we provided together now with PTV. So thank you very much, and sorry about the problems at the beginning. Hopefully you enjoyed my presentation.
Yeah, so I'll take over. Thank you very much, Eric. And yeah, I will show now how it's been used in Vissim. My name is Jochen Dormiller, work for PTV since 7 years, and mainly responsible for the Vissim product development. And yeah, so what was our motivation to do that in Vissim? Well, first, emissions are getting more attention. I mean, specifically in Europe, this is a very hot topic, but of course also in the US and in other parts of the world, like climate change and everything. And also pollution in cities is a big topic, and also where we expect fundings taking place for having more sustainable traffic management. There's a lack of integrated solutions. So we have an emission DLL. So if you want to program your own emissions model, you can do that. But of course, we want to offer to our customers an emission model. We'll do that with Enviver, which we do since, I don't know, many years, but it's an external tool, and no visualization can be done in Vissim, and it's a separate product. So that's why we chose now cooperating with Bosch and their emission model, because it can be integrated and it's very accurate, as Eric was just explaining. So how does it work in Vissim? First, you just need to prepare your model. Additionally, what is needed is to define emission class distributions. Emission class distribution is something like, what kind of vehicles do you have? How old are they? How good? How much do they pollute? Which model year? Gasoline, diesel, this information, and then assign these emission class distribution to vehicle types. I'll show you that in a minute live in Vissim. And then you just need to activate, okay, I want to have Bosch emissions to be evaluated, and activate either link evaluation or vehicle network performance. And then you just run the simulation. And after the simulation, Vissim will upload to the Bosch cloud all the trajectories, informations about the vehicles, the emission class, the gradients on the route, and then download the emission results. And then you have them back in Vissim and can use them to analyze and to visualize results. And we'll just do that. So this is a very new Vissim network. And yeah, we'll just make any network. I don't know, it's just an example network. Maybe add some spline points that it doesn't look so edgy. So this is our route, and on that route we'll just put vehicles. In that case, 700 vehicles per hour. And now we'll just, because emissions, we'll just put maybe 2 stop signs so that we can need to stop and to accelerate again, and hopefully we'll see there then emissions. So as I was just saying, there is a new object in Vissim, the distribution emission class here. So this is a new network object, and if you add one, you'll get a list. That's a specific emission class distribution with 300 elements. So we have here emission standard EU, and there we have all the Euro norm classes. And also we have here the US as emission standard. And there we also support like the different vehicle categories, duty vehicles, like commercial vehicles, passenger cars, and also emission-free is there. And you see here all there are emission stages are the year, so how old they are, and then diesel or gasoline. And if you have these data, you can enter here. So for example, you have passenger cars with the class light duty vehicle from 1980, that's probably 10%, diesel, then 92, that's 20%. I think you know that concept from Vissim. So you can provide and enter your emission class distribution. And what happens is if Vissim creates then a vehicle type which has this emission class distribution assigned, it takes from that distribution one specific emission class. So now it's 2 times more likely that the vehicle being generated will be a light duty vehicle from 1992 compared to 80. I would assume most of you don't have this data, model year and everything. That's why both for European and for also the US, we provide an example file. So if you click on File, Read Additionally, a network, then you can choose here in your examples training folder, and here vehicle fleet and settings, you'll find 2 emission class distribution, US and HBEFA is the European one. So you can select the US one, open it, and then say what you want to read additionally. If you click none for reading and then only click the emission class distribution, then these US emission class distributions being imported. That's about to give you, we're not claiming we're 100% correct with that, but we looked at the MOVES database and there were some assumptions we would needed to take, but we derived this emission class distribution from MOVES data, which should somehow represent a vehicle distribution over all the US. It might be inaccurate if you model a city in or a rural area in Texas compared to Washington, DC urban area. There you have, of course, a different emission class distribution vehicles driving there, but then it's up to you to adjust these assumptions. So what you find there is, for example, passenger cars based on MOVES year 2022. And if we filter here to the ones who does not equal 0, you'll see here, so this is all passenger cars, light duty vehicle, and then the different years, diesel and gasoline. And if we saw that, so the most ones is the 2022 gasoline, then the 2016 gasoline, 2012, and so on. And you see here the percentage of it. And the same for the different trucks with different weights, urban buses, and also gliders here. Yeah, so you have them, and you can just import them from these example files, and if needed, adjust them. So in the next step, which I was showing, was then in the vehicle types. Here, there is an additional attribute now. You can do that in the dialog. Go to special emission class distribution and assign, for example, to car, passenger car. I've already opened here these attributes. You can do that, of course, also in the list. So for HEV, we select, now let's thinking we're more simulating an urban area. There you have smaller trucks. So we use trucks 1. And here for buses, we select urban bus. Yeah, I think in the standard vehicle composition, we don't have even buses. So let's add some buses here. Maybe some percentage here. Okay, so now we have set everything. First, emission class distribution. Second, assign the emission class distribution to the vehicle types. And thirdly, in evaluation configuration, you just need to activate here. There's a new tab, emission, activate Bosch emission calculation active. And from the results attributes, make sure you have vehicle network performance and or links activated. If you don't have one of these 2 activated, because this is the only evaluation where we store emission results, then you will not make any emission calculation, even though Bosch emission is activated. So that would need to be clicked as well. So I think we're all set. We'll start the simulation. Save it as standard 1, 2, 3. And And then we'll see the first vehicles coming in. And if we look at these vehicles, so here I've already selected. So here is the emission class distribution. And you see this one, which I highlighted. This is now a passenger cars, a gasoline model year 2020. And of course, if you can have a look at all vehicles and select this, not the individual emission, emission class distribution element, just use all of them, fuel type. Then you'll see here, these are just all of them, the vehicles and what kind of emission class they use. Let's accelerate that a little bit faster. I have set here now a simulation time of 600 seconds only. So let's just fast forward the simulation. And it's now taking 1 hour. 1 hour simulation by default. Maybe we should cut that down a little bit, because then also the emission calculation. Let's stop and just change it to 600 seconds only, just for the demo purpose. Start the simulation again. So just have the 600 seconds being simulated. So now all the trajectories, they have been stored internally and are now being uploaded to the Bosch cloud. And Bosch is calculating based on each and every individual vehicle trajectory the emissions. And these emissions comes back on a vehicle level. And if we have them, we then aggregate them into your link evaluations. So into the link segments, depending, of course, how long they are, what time intervals you have set, then we aggregate them accordingly. And we'll also, so now it's done. So if we look at lists, results, network performance vehicles, there you see, so we have more emission attributes in case you want to have your own emission calculation, but CO2, HC, NOx, that comes from the Bosch. So that is for the entire network. And on the link results, so lists results, link results, you'll see these emissions based on the link segments. So 40 to 50 meters, there you have these emissions. And of course, you can make use of color schemes. So on link, select color schemes, and maybe for segments, and then we'll just maybe CO2, average, and the range is, of course, less is better. In CO2, it's up to 1,000. So we multiply that with 20. 200. So another 10. And then we'll get the results. Let's also put a legend in there. And then we see here the emission CO2, where they are. And as expected, like here's a stop sign. Before the stop, there is some emission because we have vehicles waiting. And then after the stop sign, they are accelerating again. And this is where we see emissions. Here, if they are driving fast and not accelerating, this area, there you see not so much. So as Eric was showing, like in his Stuttgart example, you can do such an evaluation yourself, but not in the real world as they have been doing. You can do that already in simulation. Just change something, put a radars, put a speed bump somewhere, and see how it will affect emissions where they are located compared to the base scenario. This is what you can do. I've prepared one example here where I used a Vissim demo file and just have run some three simulation runs and have evaluated the results and showing them here. This is the base scenario. So this is the speeds in this model. So you see here, of course, where vehicles need to stop for the red light for the intersection. We have lower speeds here. And similarly, as you show traffic KPIs, of course, you can also switch like showing CO2 as I have just been made in this other example, or showing particles where they are, or NOx. All that can be done and set up and shown. And in terms of scenario management, so I just had the idea, okay, what if I would introduce speed limit of 25 miles per hour everywhere in this network? So there were already links where 25 miles per hour have already been, but what would be if I do the speed limit everywhere? I thought of, okay, 25 miles per hour, I don't need to accelerate that much because I don't accelerate to maybe 30, 35 miles per hour. Could save some emissions, but I'm just a transport engineer. I don't know exactly. So if we look at the comparison, like in speed first, we see, okay, the scenario, the base scenario has higher speeds in terms of percent. So something like, especially here, there we have higher speeds. And if we look the same thing, compare the percent between the two scenarios, we see we'll have less emissions in the base scenario compared to the speed limits, which means in some areas here, which means we have more emissions if we reduce the speed limit. Could be because of, I didn't dig much deeper in it, could be because the coordination of the signals may not work anymore. But also maybe Eric can tell a little bit more. It depends also the temperature of the vehicle and the speed and which gear it drives. It may result in more emissions. Of course, the vehicle is driving also longer because they're driving slower, and all these effects can happen. And the simulation mode, the simulation can tell you. And of course, you could think of many other scenarios you want to test. If you change your signal timing, if you reroute vehicles, if you apply speed cameras, do some toll, whatever, restrict certain old vehicles from entering to your city, you can test that all by just creating some scenarios, make some model runs, and then having the emission calculations run similarly as other results. So this is how it works, and yeah, we think it's rather easy to use. Some methods, some notes on the methods. Currently, vehicles are assumed to start with a cold engine. So the emission calculation is very advanced. So they take, the longer the vehicle drive, they take different heat of the engine and the catalysator into account, and that has, of course, an effect on the results of the emission results. So when vehicles entering the network and you want them having a warm engine, plan for 1 to 2 minutes of warm up. We're currently thinking and discussing if we might change that, because often in microsimulation models, you don't simulate from the house to from the origin to the destination, the whole trip. So it could make more sense to start with a warm start, but it's something we currently discuss. Emissions affected by the gradients. So make sure you model gradients in there, and it's also been sent to Bosch Cloud. Emissions are sensitive to acceleration. I've seen some Vissim models where they used acceleration for calibrating towards something. And of course, if you take too much acceleration and deceleration, that will have an impact on emissions. So make sure your acceleration are about right. And the currently supported emissions, you have seen that in the Vissim model, is CO2, CO, NOx, HC, particle mass, and fuel consumptions as well. And it requires an internet connection because it's a cloud product. Yeah. And then, of course, as you may know, you can make use of the emissions, so the vehicle network performance, the link evaluation, and use them in lists, visualization, charts, video recording, scenario comparison, everything what you know from Vissim, how you can make of it. So if you want to test it, that is, of course, possible. Because we need to pay fees to Bosch, it's a add-on module, but you can have a test license. So you can contact us or PTV America, of course. Here's a direct link, free testing. There's a landing page as well if you want to read later more information. Yep, and that's it. And yeah, thank you very much.
Thank you, Eric and Jochen. We do have some questions that we'd like to have you guys answer. And if you're fine with that, I will go ahead and read some of those off. The first question that would be good, well, they're all good. First question is about grades. So what about grades? Does that impact acceleration and deceleration, and especially when there's hilly terrain? And maybe Jochen, you can address that one.
Yeah, so on both sides, of course, in the simulation, it affects. Make sure you have your gradients right, and then it will affect acceleration and deceleration. If they need to go uphill, they need to accelerate more. And also, when we do the emission calculation, we send this information about grades to Bosch, and they take the gradients into account in their emission calculations.
Great. Here's a multi-part question. The first part says, does the plugin of the Bosch emission model support online estimation during simulation, or does it only provide results after the simulation?
Yeah, the second is right. So yeah, we collect the trajectories during the simulation, but we'll wait until the end of the simulation to then upload all the trajectories and wait for the emissions coming back and then having them aggregated in the results. So not during the simulation.
Okay, and the second part is, does the emission model apply to scenarios in other countries or regions?
Eric, do you want to answer that question?
Yeah, I can answer this. So at the moment, it's we have emission models available for European cars and for US cars. And that means because legislation in many countries are oriented on US legislation or European legislation, because, for example, China legislation is quite similar to European legislation. So it's especially for Europe and US, and in this case also Canada and Mexico. For other region, it's suited also quite well, but we at the moment we are working especially exactly on this, that we also can provide emissions for Asian regions or other worldwide regions. That is, but this is still on our working plan.
Okay, great. And then two questions related to potential other things that may or may not be considered in the model. The first having to do with brake and tire wear emissions, and then the second having to do with meteorological information like temperature and humidity. Are any of those 4 items, for instance, considered?
So the first one is no, unfortunately not yet. It's also on our working future work. We try to do this until end of this year to implement also tire and brake wear. We see, especially with new WHO guideline, that especially PM 2.5 and then brake and tire wear will become much more important. And we react on this, and we want to develop here also brake tire wear in future and provide this to our modeling. At the moment, it's not available. And the second question was, I'm not sure if I got it completely right. So we take into account it is possible for our modeling that we take into account ambient temperature, and but at the moment this is, I guess, not with Vissim possible to say it's -7, it's -40 degrees, or it's +20 degrees. At the moment, the cold start for us is at about 20 degrees, yeah, that's the case.
Okay, great. Thank you very much. The next question starts out with a statement, says emissions a big topic in the US, and wondering if this tool has been field tested here, and then going in to describe our congested freeways and different vehicle compositions and large commercial trucks and et cetera. But I think the heart of the question is regarding field testing.
So Jochen, you want to answer, or?
Well, our part, I think Vissim itself, the micro simulation, has been somehow standard now in the US and being used for these studies. The Emission part is something, of course, Eric, you need to reply.
Yeah.
And then, of course, the combination is also a question. So even though the Emission is perfectly fine and absolutely accurate, but then, of course, it's always compared to real emissions for real vehicles. And the question is, how good are simulated trajectories of the micro simulation models to emissions? That's something we currently investigate in a research project. It's here in Germany, but we want to make sure, okay, how good are we generally with some default values on micro simulation models in terms of emissions?
And
Okay,
from the emission side, yeah, maybe just, so it's quite new. So we did not projects with our emission modeling in the US yet. What we did in the development phase is to validate also our US modeling is, so like I said in my presentation, we taking the trajectory second by second, evaluating out of this the power needed from the cars, and go then into this emission and from PM, NO2, and so on. And these engine emission maps, they are consistent with the MOVE toolings. So we compared them with the EPR, Environmental Protection Agency, curves and maps from emission side. They have inside for every vehicle type, for every fuel type, and also for every model year, and they are consistent with this. So you will get definitely accurate emission values out of this modeling, but real projects, that is because we are just starting with the US legislations emissions. Yeah.
Great, thank you. Jochen, I know you answered this in the text, but I think it's a good one to ask for everyone to hear, which is, how long did it take to get the model results for the grid network that you showed in the presentation?
Do you see my screen?
Yeah.
Yeah. So if we look here, so this model, I think, did I change? I only ran half an hour of that model. This results simulation runs. So I started the simulation at 2 o'clock, and then it took 12 minutes, the first one, and about, well, 16, 17, the second run. Yeah, so about that time it took for running the simulation and doing the emission calculation. Yeah. So half an hour simulation run, half an hour simulated time, it takes 10 minutes for that model, real time.
Great. Do you report idle emissions?
Idle emission,
yes,
is that
idling? So when the vehicle stands still, we don't take at the moment into account start-stop systems. But so at this point, when a vehicle stands still, or even over a longer period, and you simulate it like this, that it's then we also take into account idling emissions.
Okay. Fabulous. Johnson, did you want to close us out? I think we're nearing the top of the hour. I believe almost all, if not all, of the questions were answered. Any that weren't, we will follow up directly.
Yep. So, yep. Thanks, Bill. Thanks, Jochen. Thanks, Eric. I hope that like this session was like useful and helpful. And as Bill was saying, that like if there were any questions that were not being answered during the session, we'll get back to you via email. And some of those contents are going to be posted like to a place where I showed you, Technical Resource Hub, and also you're going to get a follow-up email after that, so that you can get access to those materials that was being shared today. So if you have any questions or concerns, or the feedbacks, anything, let us know. We're here to answer or talk with you. So with that, I would say that see you in 2 weeks in our next PTV talk session. And thanks for joining today's session. Right, thank you, and have a great rest of the day. Thank you.
Thank you very much.
Goodbye.
Bye.